In this video, we'll discuss parallelograms and rectangles. Now first, what's a quadrilateral? And a quadrilateral is any shape made of four line segments. So this can be concave or convex, although primarily we deal with convex quadrilaterals because the sum of their interior angles is 360 degrees. So if we look at these two different groups, we can see on the left we have four segments. It's closed, and even when it's concave, they're still considered a quadrilateral. Whereas on the right, you've got curves, an open one. This is not considered quadrilaterals. Now, one of the special quadrilaterals we talk about is the parallelogram. It's the first of a series of special quadrilaterals, and it's the most broad of them. And in this case, we know that it is a quadrilateral with opposite sides parallel to one another. And this produces several different distinct properties. First, because they're parallel, the opposite sides end up also being congruent. Their diagonal interior angles are congruent, and the consecutive angles have to be supplementary, as well as the diagonals bisecting each other. So if we think about these first three items, it's all because of the parallel sides and how everything gets created. So if I know two of the sides, I know the opposite sides have to be 6 and 12. Now if I know this angle is 70 degrees, by the definition of what happens with the parallelogram, I know this opposite angle is 70 degrees, and I know the other two have to be 110 degrees. Why is that the case? Well, if we think about parallel lines, we have two parallel lines cut by this transversal, hence why interior, same side interior angles sum to 180 degrees. And then if you think about, here are two parallel lines cut by this transversal, same side interior angles have to add up to 180 degrees. Therefore, the diagonals have to be congruent. Now, say that we had the diagonals drawn into the parallelogram. What we recognize is that they bisect each other. That means they cut each other in half. So if I know that this segment BE is equal to 10, then I know that ED is equal to 10. Now say I knew that the entire length of AC was 14, I'd know then that AE and EC both equal 7. Now another special quadrilateral we talk about is the rectangle, and it is a special type of parallelogram. So if we think about a group, we have parallelograms, and inside that group is a special one called the rectangles. And the rectangles are parallelograms with four right angles. This helps with a couple different aspects. First, it takes those diagonals that can be constructed inside the rectangle and they become congruent because of that 90-degree angle. We still have the opposite sides being congruent and the diagonals bisecting each other. So it does do all the same properties that hold true in a parallelogram hold true in a rectangle as well. Just these special things are added. So first, you know that if we have two sides, we know their opposite sides are both 5 and 12. Now if we think about drawing in a diagonal, say GI or FH, either one is fine, we see what we have here are two right triangles. So what we can use is the Pythagorean theorem to find the length of diagonal GI. So 5 squared plus 12 squared, and then you take the square root, you'll end up with that being 13. FH would have the same length. Now let's think about the idea of if we have the diagonals on the inside. We know that again, we could use Pythagorean theorem and get, since this is 6 and this is 8, using Pythagorean theorem, that BD or AC are both 10. So, since they are congruent and bisect each other, we know that all the smaller segments to E, AE, EB, EC will equal ED, and they're all going to be 5, because 5 plus 5 has to be 10. So if you look at that, what that creates is 4 isosceles triangles with the opposite, the ones that kind of invert on each other, being congruent to one another. They're congruent triangles by side, because this is 6, 5, 5, and 5, 5. So what that also means is that they have congruent angles as well. So if I know one angle, I can find every other angle in this image because I know the corners have to add up to 90 degrees since they're right angles. And I know that since they're isosceles triangles, that the corner angles in the same triangle will be the same or equivalent. So if this is 40, I know these other three are 40. And if this is 40, I know that angle BAE would have to be 50, which means all the other three angles would have to be 50 degrees. And then I can use the idea of a triangle to recognize my four angles left in the center would have to be 180 degrees.